Hi, my name is Jamal Ashraf, and I want to cover chapter 4 of big Java book from Wiley. So I broke this down to 4 pieces, and I'm going to do it in 4 parts for each section for it. Uh, so the first one is going to be about numbers. The chapter 4 is about data types. So we're going to talk about the numbers first. So in Java, being object-oriented language, almost everything is object. So we have classes. From classes, we create object and we use it, except 4 primitive types. So 4 of them are not actually going to be objects, which later on we learn how we can cast them to be object. But for now, these 8, there are going to be 4 of them are integer and 2 of them are floating and 2 other ones. And for our purposes, for our class, we're going to be just using a couple of them most of the time. So let's look at them. So we talk about the int. Int is 4 byte, and that's the value that it can get. Let me do this. Byte is the smallest one that we can use. Of course, if we have very, very small number, we should use a byte. But nowadays, with the computers that we have, the storage and the speed and everything we have, we are not worried about it that much, except we get to the small footprints. Like if we want to do something, let's say in device driver or things in that, maybe we're going to be looking at these things. Short is half size of the int, so that's much smaller if we are concerned about the storage again. And long is double of int, and we talk more about that. We have float, that is 4 bytes, is using decimal points. And of course, double is a double size of the float. Character, because we are using a Unicode, is 2 byte. Originally, it was 1 byte. ASCII table was 1 byte. And we are using Unicode, which you can look more detail on it. And the smallest thing that we can have is a Boolean, which is 1 bit. It's 1/8 of a byte. So just very, very small. If we are concerned about the storage or the place that we're going to be creating our variables, so Java, like C++, assigns as much memory as possible before running the program. So it does calculate all of these things. So the numbers that we're going to be using in our program, but basically it's going to be called a number literal. It may have a decimal or not. If it doesn't have a decimal, we're going to be using integer. If it does have a decimal, we use double or float. And the rule of thumb is you shouldn't be using double for everything. Some people try to do that. They just put double for everything. That's inefficient programming. So these are some examples of the numbers, and the one with the decimal. The one with the decimal, we have the E. That's just like in your math, you would have to the power of something. So E1, E6 is the same as 1 times 10 to the 6. That's also available. We can use the E to the negative number. So E to the -2 is 10 to the -2. If we need to do that, we can put an L in there for long. We cannot put comma, we cannot put underscore, and we do not have this format, but the rest of them can use it. This is Okay, so because we have limited space, because first of all, computer doesn't have unlimited space, and we are defining our data types, and we talked about how much each one of them is going to hold. And it is our responsibility as programmers to kind of figure out how far these numbers go. So we have to find a balance. Of course, you can put big, huge space. And the analogy of that is, yes, I can come to the school with a 18-wheel truck, but that's not efficient. Just because we can use bigger storage doesn't mean it's going to be efficient. So if I'm using int or byte or short, they have limited space. And eventually we can go outside of the space, just like the picture shows that if I have a glass of water or soda and I keep putting in, it's going to overflow. And overflow generally is going to end up with a negative number because we are using the most significant bit for the sign. If it's 1, it's going to be negative. If it's 0, it's positive. I don't want to go to the details of it. But if you are having questions on that, I can go over it with you individually. You can ask me, I can go over it. So that's why if I have a number of 1 million and I multiply 1 million by 1 million, I'm getting negative number. This indication of overflow. So we should all know our limitation, and I would generally not go to the boundaries. I would just say, you know what, if my numbers are getting much longer or bigger, then I have to start looking. And then you know that in your environment. So your book is talking about the population of a country versus the population of the whole world or population of multiple countries. So that's where we're going to get out of overflow. There is another thing that's called rounding error. So the numbers, because we are using base 10 and the computer is using base 2, the number can potentially not fit the way that we are thinking about that's going to fit. So we might have some rounding error. So for example, if I define a double for 435 and I multiply it by 100, I don't get 4.35000. So that 35 is actually saved as 34,99999, and maybe something else at the end of it. I want to talk about the final. I know I have talked about this in class a little bit here and there. So we don't want to have any magic numbers in our program. Magic numbers are numbers inside the program, and then yourself or somebody else come to the program a few weeks to a few months to a few years, and then they see a number, and that number doesn't make any sense. For most of you wouldn't be there, but we had an issue in year 2000 that the years were saved in 2-digit, of course, because of the storage limitations that we had. And then the 2-digit going to, let's say, 1999 was saved as 99, and then 2000 was saved as a 00. And then 00 was not higher than 99, so it was causing some problems, and we didn't know how much of issue we had. So for some bad programming, we had to go through every program in every location of the company, look at the numbers and figure out if that number is year, and if it's a year, to change it. It was a big, huge task worldwide, and we were able to do most of it. Some companies were under because they couldn't do it, but it was done. And that shows that if we get together, we can get huge tasks done. So saying that, we don't want to have any numbers in the code. We want to define them. We're going to put some variable on it, and we're going to call it final, basically because we don't want them to be changed. So I wake up in the middle of the night, I go to my coding and I'm trying to do something, and then I say, well, if I change this one, maybe that's going to fix my problem, which actually that thing shouldn't be changed. It can change, but it's only going to be one location. So we have two reasons to use the constant variable. One is we have the name of it that's going to make sense. So instead of 10.25, then maybe I can say tax rate or sales tax rate. That makes a lot more sense. And on the other side of it is I don't have to change it throughout my program. I just change it in one place, and then it's going to be done for everywhere. And later on, we're going to learn that it doesn't even have to be in one class. It can expand to multiple classes. So if I have 10.25 and I have 10.25 all over the place, then I have to, if I want to change the tax rate, I have to go find the 10.25, figure out if that's a tax rate in that location, in that part, and then change it to 11 or whatever it's going to be. And I have to repeat this every time. But if I define it as a final, then I just go to that one and I change it. That way I don't have to worry about it. So then the convention is we're going to put it all uppercase. So whenever I see it in the program, I know this is a constant variable. These are some examples that we have from the book. So we have final, double, quarter value, 0.25, instead of just putting 0.25 in the middle of the code. So moving forward, we don't want to see any numbers in your code. So you have some numbers, you're going to come up with some kind of a meaningful name for them, and you're going to define it as a final. So final is going to be inside the method. So I'm defining this constant for a method. Now, if I want to use more inside of more than one method, if I want to use more than one method, I'm going to use the word static. So if I use a static final, then I can use it in more than one method. Now, what about if I want to use it in more than one class? So I can set it as public static final. Then other classes and everywhere else, they can use it. So a good example of that is the math class, which has a bunch of variables and bunch of methods that are defined as public static final. So when it's defined as a public static final, I don't have to create an object. I don't have to I don't have to import the class. All I have to do is just put the name of the class and put what I'm going to be using. So I am going to put the name of the class and the variable or the method that I want to use from that class. And if it's defined as a public static, remember, it's going to be public static, then I can access it. So we're going to be using the final, and then we're going to put the value for it. This is for a method, and we're going to be using public static final if we want to use it more than one method and more than one class. So anybody from outside can check this liter per gallon. So I am defining it in one location and everybody can use And if in case I need, of course, liter per gallon is not going to change at all. But let's say that if for any reason we want to change it to have more precision or have to do something else, all I have to do is just come to this one, change it here, and everybody else, the whole company using this, they don't have to worry about it. They don't even have to think about it. Versus if I didn't define it like this, I had to go to every program, every class in the company, find that number, and then change it. Okay, naming variables. I want to go over this to be sure that we understand this. First of all, name should describe the purpose. So I have asked, and I will ask you, when you have one single character or you have some abbreviation, I'm going to ask you, what does that mean? So I have CV. The CV means can volume. So let's put can volume, not only for you, for other people who are going to be looking at your program in the future. So no magic number in your program and no abbreviated names for your variables. So first of all, we can start with a character or underscore. Python is using underscore for all instance variable of a class, and that's the way they create their standards. Some people like to do that, but it's available. And then the rest of it is going to be letters, digits, or underscore. That means we cannot have any special character. Most of you know this already. Between the words, we want to use the capital character, so it's going to be easier to follow. So if I have camel hump, if I don't put H as a uppercase, if I put it as a lowercase, it's going to be harder to read. And of course, we cannot use any reserved word. So I cannot call my variable int or double or anything in that matter. Okay, so the cash register is a program. Let me find it right here. So the demonstration of the final variables, we are putting it over here as a public static final for quarter value. And now this quarter value can be used in other classes, other program, other places by calling the name of this class and then quarter value. And again, I want to emphasize that it's all uppercase and the words are separated with underscore. And we want to put this on the top of it. So when it's here, it belongs to the class. If I had it in the method, it would belong to the method. If it belongs to the class, all the methods can use it. If it belongs to the method, only that method can use it. So we have a default constructor that's going to set everything to 0. We should generally have a constructor that takes some parameters. My rule of thumb is if I have 2 parameters, I should have one with 2 parameters. Sometimes you want to have multiple of these constructors. So let's say that I want to have built an object just with the purchase or just with the payment. We can do that. So here I'm creating 2 constructors. One is for default one it has 2 parameters. Your book doesn't have it. I just decided to put that one in there. So for the recording the purchase, we get the amount and we're going to add it to the purchase. So that would be purchase plus equal amount. For receive payment, we're going to receive dollar, quarter, dimes, nickels, and pennies. And then we multiply them by our constant variables to get its value. So if I have 2 quarters, I'm going to multiply it by 25 cents. I'm going to get 50 cents and so on and so forth. The pennies doesn't really need a penny value because it's just 1 cent, but for the sake of practicing, we have it over here. And of course, when we're giving the change, we can figure out how much is the difference to give it back to them and then return the change. You can potentially check it to be sure that your purchase is not higher than your payment. That would be if the payment is not enough. So if the change is negative number, that means the user hasn't given us enough payment. So we're going to start with some checking on the. So this is a tester program. Remember, tester class or program, whatever we want to call it. We are writing classes and then we're going to test it. So minimum, we need 2 classes, one your class and one to test it. And we keep adding classes to it. And as far as they are in the same project, we don't have to import them. They are in the same place. So when I'm testing my class, I want to test for everything. So remember, you're writing a class, you want to give it to other people to use it or add it to a project or something. So everything that I have here in my cash register, I want to test it. So give change, receive payment, record purchase. I want to test all of these things, including my constructors. I want to test them all. So I want to test to be sure everything is okay. So we calculate things by hand and then we test it to be sure it's going to be okay. So I'm creating 2 cash register, one with nothing in it. The second one, I'm putting some money and payment in it. Then we are just calling some methods that we have, and then we print it. On the second one, what I did add to it is for my register 2, I am getting the change, and I want to show you the formatting that's coming up to see the difference. So if I run this one, so I have change of 25 cents. It was expected to be 25 cents. I got change of $2, was expected to, and that's going through these things. And then the static value of the quarter outside of the object is 0.25. This is where it's coming from. So remember, cash register was here, and I'm calling its a static variable right here. So we can do that outside of the class because it's public static. And then if I do register 2, if I don't format it, this is what I get. And if I format it with the 2 decimal point, this is what I get. I'm going to talk about this printf shortly. Okay, so when you get a pen and paper or bring up a document, we're going to go over these self-checks. I want you to think about it. If you need more time, pause this and go over it, and then we can answer it in our class. So get something together, and I'm just going to mention these things, and it's going to be in our modules for you to answer them. So the first one is, which are the most commonly used number type in Java? Go ahead, put it down. Next one is, suppose you want to write a program that works with population data from various countries. Which Java data type should you use? I just mentioned it a few minutes ago. Which of the following initialization are incorrect and why? Again, you can pause it anytime and think about it. That way you don't have to be pressured on it. You don't have to answer it right away. And what is the difference between the following two statements? So go ahead, think about those. What is wrong with the following statement? So that was what we had for the first part. I'm going to stop it right here, and then we go for the second part.